We're going to look at the characteristics of linear, quadratic, and exponential functions. There's quite a few differences between the two and some similarities, but we'll look at all three as a group and then use our knowledge to compare the three together in this unit as well. So the first one for graphs, when we're looking at graphs, is linear functions. Linear functions are always going to have a graph that appears to be a straight line, like so. Now, that straight line could be increasing, it could be decreasing, but it will be a straight line. Quadratic functions always have a U-shaped curve. That's called that parabola. The parabola could be facing up, or the parabola could be facing down. It doesn't matter. These are both just examples of parabolas, and we'll talk more about those in a few minutes as well. Exponential functions always have a J-shaped curve that's either increasing or decreasing. Example here, this exponential function is an increasing J-curve. Now with the equations, we're just going to look at the standard form of each one. You'll notice some similarities and some differences in these as well. With equations for linear function, they are typically in the form of f of x equals mx plus b, where we have a slope and a y-intercept. The slope would be m, the y-intercept would be b. Notice that the power on the x value is just 1. We don't see it, but we know if it's not there, there's a power of 1 that's there. Quadratic functions, the standard form is f of x equals ax squared plus bx plus c, where a, b, and c are constant values, and c is our y-intercept. There's also two other forms of quadratic functions, including vertex form and factored form as well. Exponential functions typically fall in the form of f of x equals a times b to the x power. So on this one, notice we have an exponent, and the exponent is the x value itself that's changing. B, our base, is not changing. While in quadratic, a good way to tell the difference between the two is quadratic, it's the base that's changing for our x. The exponent itself is always 2 for a quadratic function. With tables, when we look at the pattern of our y values in a table, in linear functions, there will always be a constant difference in the table, meaning that our y values will constantly be changing by some sort of adding or subtracting pattern. With exponential functions, we're going to jump over to this side. With exponential functions, there's always a constant ratio, which means when you divide any two consecutive y terms, you would get the same ratio. With quadratic functions, there's a constant second difference. And what that means is when you look at the first differences from linear functions, there isn't a constant pattern. But when you look at the difference between the differences, or that second difference, there is a constant pattern. Our next one is domain, and domain for all of our functions in Algebra 1 is always all real numbers. Now, the reason why it's all real numbers is because we could substitute any x value into our equation and get a corresponding y value. So how we write all real numbers, if we're writing an interval notation, would be from -infinity to infinity. Or if we're writing in an inequality notation, it would be from -infinity to +infinity, like so. And like I said, every single function in Algebra 1 has that same domain. The last one for this video is range. The range for different functions all vary. The range depends on a few different items in our parabolas, or J-curves or straight lines. So the range for linear functions, since it is a straight line continuing both directions forever, our range is also from -infinity to infinity, or if you write it in inequality notation, would look like this. Our range for our quadratic functions, a key thing to look at is the vertex. The vertex is really going to define that range. So we would write here that it's based off of the vertex. And then the range for our exponential functions is always based off the asymptote. And with these functions,